Hello everybody, this is Peter and today I would like to show you a new project I've been working on. This project was all about time series and models that generates them. So let's start with the basics. A time series is a sequence of data points measured typically at successive points in time spaced at uniform time intervals. This is a simple time series. Time on the x-axis and values on the y-axis. In this case, it is obvious that the model that created the sequence of numbers was just a combination of some rising trend and a few sines and cosines. In real world, sadly, we encounter much more complicated cases of the similar thing. Just by looking at Apple stocks, it is clear that modeling this kind of evolution would be impossible using simple models. This is where autoregressive model comes to mind. This model tries to define every value as a weighted combination of preceding values. Now we need to look at this problem from a different point of view. Checking this time series, we can easily define areas where the model suddenly changes. So there is a state of rise and a state of stagnation. Now the only thing we need to do is come up with some clever way of determining which state are we currently in automatically and put it into eye-pleasing user-friendly cover. So this is the app that I came up with. Main screen is devoted to a preview of a given time series. This one is a sample that the app loads up with. As you can see, I can freely pan by holding middle button and zoom with mouse wheel. All this rendering was custom coded in .NET and GDI in order to provide best experience for the user. Proportional zoom is often not enough, and for that we've got these two sliders. With their help, we can zoom horizontally or vertically around the last position of cursor on the viewport. Cursor provides us with other useful information. On the top part of the screen, we see interpolated value between two closest points. On the right side, an information about current time is displayed. Importing your own time series is very simple. Just click File, Open, and choose either RAW file or Excel file in format of Yahoo Finance stock data. RAW is probably the best choice since it's basically just a sequence of numbers in a text file. So let's load some data into the app. If you mess your viewport up, you can always double-click middle button to fit the graph to the screen. We would like to start by estimating simple autoregressive model parameters. These parameters are basically the weights used to multiply the preceding values in order to get the following one. If this explanation is too brief for you, you can always check Wikipedia for more information. The best way of determining correct AR parameters count is to simulate more models and plot their respective RMS. This area, where it stabilizes, probably contains the right AR parameters count. So in this example, 3 legs seems to be the right answer. This, while interesting, is very hard to verify. That is why we rely on a simple method of calibration. First we simulate a known model and then we try to estimate it as if we didn't know it beforehand. Simulation tab serves us well for this purpose. We just need one state with probability of occurrence equal to 1. I'll get to probabilities in detail later on. Last thing we change is the length of a time series. 5000 values will suffice. Now we try to estimate 3 legs AR model and compare it with the original values. As you can see, we estimated it pretty well. Finally, we are getting to Markow switching model. Go back to simulations and leave two separate AR models. Left mouse button click to add and right to remove models, just to clarify. Probabilities in this case describes the way of moving from one state to another. If we are in the first state, this is probability of staying in it for another time step. Second row is probability of moving to second state. Just like that, if we are in second state, this is probability of moving to first state, and once again on the diagonal is the chance of staying in the second state. There are a lot of information concerning Markow switching model online if something was left unclear. Now we move to new tab, MSM. This is where all the magic happens. We just set number of states and number of legs in each state and hit generate. We are using nonlinear minimalization, so we can use convergence criteria as a way of balancing speed and precision. Number of buttons became available, so we can inspect their purpose. You can save estimated model using the Save button. Convergence plots a graph of convergence, the process of estimating the model in the means of improving logarithmic likelihood between data and proposed solution. Probabilities button plots probabilities of every state occurrence in time. The biggest value defines state, therefore this area describes the part of time series where the first state occurs. You can distinguish one from another by colors. Red is first and blue is second state. Simulation shows original data in red along with simulated series in green color. Now we can move to actual solution and compare it with the original model. Once again, you can see that the model was estimated more or less correctly. There is random noise present in every time series, therefore you can never get perfect solution. However, precision improves with the length of the time series. This time it was easy for us because we already knew number of states and AR parameters. In real life, things are not that simple. In order to obtain the knowledge, we need to run some tests. First available test is Bayesian criterion used to estimate just that. This test estimates range of different models and it assigns a value to each one of them based on a mathematical formula. The lower this number gets, the better. Gold model is the best one, and green is best for a given number of states. Next test is called linearity against nonlinearity. It tells us if we need to use more than one state. In other words, it ensures us whether Markow switching model is actually needed or if autoregressive would suffice. Remaining nonlinearity tests works the same, but it is deciding between 2 and 3 states. This way, we can spare valuable time while estimating our time series. Finally, we are moving to prediction. This step provides us with ability to predict time series values and verify the prediction by comparing the original data. RMS is calculated as a statistical guide of how good the prediction was. I hope you liked this tutorial. Feel free to leave any comments. I will try to clarify any confusions for you since I know I ran over it very swiftly. Finally, I left the download link in the description for you to try these features out on your own. See you soon, bye.